the most useful do stats options today. A lot of what we'll talk about, at least some of it will be new or something that you don't typically pay attention to when you're running update statistics. And it's useful to know all of these things so that you can get the best data distributions possible for your database and improve your query processing as much as possible. So let's get started. So first, some of the basics, just to get everybody on the same page. Update statistics updates data in some of the system catalog tables. Okay. Basic statistics details are stored in sys tables, sys columns, and sys indices. And data distributions are stored in sysdistrib, and for certain fragmented partition tables, also in sysfragdist. Update statistics also optimizes or recompiles stored procedures, and it also will trigger index rebuilds if you run it after updating your server to a version that happens to have some internal differences in the way the indexes are laid out. Okay, so it is important to run update statistics after a server update. We'll get into that a little bit later. So update statistics can be run in 3 different modes, low, medium, and high. Low mode is the least, gathers the least amount of data, and it updates sys tables, sys columns, and sys indexes. And it does not update sysdistrib, so it creates no data distributions. If you add the delete the drop distributions option to update statistics low, it will also clear out existing distributions. Okay. High is the most detailed and gathers the most accurate data on the contents of your tables. All right, it performs at least one full table scan, and it may perform more than one, especially if you're running it against multiple columns in a single command. It updates sysdistrib and possibly sysfragdist. The default resolution is 0.5%. Resolution specifies how many bins the distributions are broken up into. So the default for high is 200 bins, or 0.5% of your data in each bin. Okay. Medium data does calculate distributions, but it does it by sampling, not by performing a full table scan. It is faster than high and updates sysdistrib and possibly sysfragdist as well. The default resolution is 10%, creating 40 bins. Okay. But it does not scan the whole table. So there is some difference between the quality of medium distributions and high, which you can adjust with some options, which we'll talk about in a little bit. Okay, if you run update statistics for routine or for procedure or for function with a procedure name, it will recompile that stored procedure and produce a new query plan for the procedures to run with. Okay. What's gathered during update statistics low specifically? So in sys tables, it updates the number of rows, the number of data pages, and the time that low stats were last collected for the table. Okay. The number of pages and the number of rows in sys tables are not maintained dynamically. So that data gets stale, and the optimizer can't necessarily use it. Okay. Sys columns, it will update the second largest value for a column and the second smallest value for a column. Okay, and obviously if that column is a very wide column like a char or a varchar or an lvarchar, that's only going to be a partial kind of second value. In sys indexes, it updates the number of unique values for the lead key column in the index, and the width and the depth of the index structure, how many levels it has and how wide it is, how many nodes are on the widest level. and how highly clustered the values are for the lead key if it's a clustered index. Okay. And that will tell the optimizer whether or not it can rely on the clusteredness of the table, or if it needs to go back to the index instead of doing a table scan once it finds the first key it's looking for. Okay. If you only have load statistics and you have no data distributions, the optimizer will behave as if it did in version 5 of Informix, basically. It doesn't have a lot of information, but it does its best to use the information in systables and syscolumns and indices or indexes to make decisions. So data distributions, though, allow the optimizer to make much better decisions, right? It tries to guess for a particular filter value or a particular join column, whether or not it can use a particular index to improve performance. And also it will decide which tables in the list of tables in the from clause to query first and which to join next, etc. So with as we mentioned, with update statistics medium or high, you're going to create data distributions, okay? And those distributions are mapped by column into a set of bins, okay, for each column. And any particular value within the bin that has more than 2% of the data, right? With 50 bins, or basically more than 25% of the values in that bin, it's pulled out as an outlier and made a separate entry, and then the number of keys and the number of values of row values in each bin is reshuffled and readjusted. Okay. The resolution is the percent of data that's held in each bin, right? So for medium, the default, as I mentioned, is 2.5% for creating 40 bins. For high, it's 0.5%, creating 200 bins. And one way for very large tables to improve the quality of the distributions without adding a whole lot of time is to increase the number of bins, to increase the resolution to a finer resolution. Right, so to add, for example, go from medium from 2.5% to perhaps 1%, so that there are 100 bins, right? Or for high to go from 0.5% to 0.2%, right? So that there are there are 500 bins. Okay. Sorry. So the optimizer uses the distributions to decide where the what join columns to use, which index to use, what the query plan should be, right, and what query path to use. Start with the first table, start with the second table, etc. Okay. In order to create medium or high distributions, you have to have DBA privileges on the database or be the owner of the table. Okay. You can see what the distributions are using DB schema with the -HD option, and that will show a histogram of the data, which we can get. Right now, that report will look something like this. At the top, it will tell you the name of the column, when the distributions were last constructed, and what mode they're in: medium mode, high mode, what the resolution is, and what the confidence level is. Okay. In addition, that first section right after that, where it says distribution, those are the bins. In this particular table, there was only a small number of values that were not outliers, and then below that are the overflow buckets, which each have one key value in them. Okay, and those are the outliers that were pulled out of the buckets. So in order to collect the distributions, the optimizer has to make several decisions. Okay. If auto mode is not set for the table, and if it's not the default in the onConfig file, right, in the stat mode onConfig variable, or if you use the force option when you run update statistics, then we're good to go and we can calculate distributions. But if any of those are not, if all those are not true, if we're not If we're in auto mode and we're not doing a force, okay, or then the table is set for auto mode, then the next thing is to determine whether or not the distributions are stale. If they're not stale, then the engine will not do update statistics at all. It will no op the procedure. So we'll check to see if what the auto distributions mode is for the table itself. Okay, and again, if everything is, then if it's in auto mode, it will look at the number of inserts, updates, and deletes that were present in the against the table at the time distributions were last gathered. That's stored in the sysdistrib record and also in the sysfragdist record. Okay, and it will compare the current levels of inserts, updates, and deletes against what was stored at the time the distributions were created. If the percentage change exceeds what's set in the stat level for the table or in the onconfig file, the default stat level, then it will calculate new distributions. If not, it becomes a no-op operation, update stats, does nothing, okay, for that particular table, or indeed for that particular column. Okay. Note that if you change the sampling size, the resolution, or the confidence from what it was last used to calculate distributions, then the auto mode is ignored, and you'll get new distributions no matter what. Okay, that's important. It's not well documented. Okay, so first thing that happens is the optimizer or the engine develops a scan plan. Can I do this all in one scan and resort the data, or do I have to make multiple scans? How many columns can I fetch at one time? How much memory do I have? And we'll talk about memory in a little bit. Then we're going to scan the table using isolation dirty read. For high, we're going to scan all rows. For medium, we're going to sample some percentage of the rows, and we'll talk about how that works in a bit. Then we're going to sort each column that we fetched, okay, that was mentioned in the update statistics command. Collect the distributions for them, and then distribute it into bins. Identify any outliers, and then rebalance the bins so that each bin has roughly the same number of row IDs identified in it. Okay. Each bin is going to have a small number of key values, and then it's going to have a larger list for those key values of what rows have those distributions, those values, or how many rows have each of those values rather. Then it will open a transaction against the catalog tables, delete the old distributions, and insert new distributions, commit the transaction. Okay, and then the last thing it will do is mark the cached distributions in memory as stale, so they get reread the next time somebody processes a query. Okay. Partition level distributions. So if you have a partition table, okay, it is optional that the engine might decide to calculate the distributions for each fragment separately, in addition to the full table distributions that are always calculated. Okay, so if you alter table set the stat level to one of three values, table, fragment, or auto, that helps the engine decide whether or not to calculate fragment level distributions. If you set it to table, then no fragment distributions are calculated. If you set it to fragment, then each partition gets its own set of distributions in the sysfragdist table. If you set it to auto, then the optimizer has to make a decision. If the table is partitioned via expression or by list or by interval range or interval and or range, it has at least 1 million rows in it, then the optimizer will calculate partition level distributions. Okay, if it's fragmented by round robin, for example, then it will not get fragment level distributions unless you explicitly set the table to fragment distributions. Okay. Let's see what else. Fragment distributions are not available before 1170. So if you're still running 1150 or 1110, there are no fragment distributions. Okay. Also note that the fragment distributions are stored in an SB space, in a smart blob space. So if you do not have a smart blob space, you have to create one if you want to expect to get fragment distributions on your partition tables. Okay, and you set that smart blob space in the sysSB space parameter in your onConfig file, so the engine knows where you want those distributions to go. Okay, if you don't have an SB space set in sysSB space, then update statistics on a table that needs fragment distributions will get an error. You won't get, the distributions will not run. Medium. So you can use the resolution clause to adjust the number of distribution bins, as I said. You also get to set the confidence level as part of the same resolution option. The confidence level is percentage of confidence that the medium distributions are as good as high distributions would have been. Okay, the default is 95%, 0.95. You can set it to anything from 0.8, 80% to 0.99, 90%, 99%. Typically at 0.99%, the statistics will be really close to high. Okay, but keep in mind that a relatively small number of rows will be sampled by default. Okay, which gets us into the sampling size option, which we'll talk about in a minute. So, for example, if you have 100,000 rows in a table, the resolution is set to 2%, you'll get 50 bins, okay, etc. Okay, sampling size. So this one, pay attention if you want to use sampling size because half of this is not documented, okay. It specifies well, it actually says I wrote minimum, but it actually specifies the maximum number of rows that will be sampled. Okay, and you can set that to any value from 100 to the number of rows, and it will be valid. If you set it to 100, it actually behaves as if you didn't set it at all. So really, it's 101 and higher, and that will sample roughly that number of rows. Okay. If you do updates, if you do a sampling size, for example, of 120,000, it will sample roughly 120,000 rows. Okay, the confidence level will adjust that, and there's some documentation about a little more details on how that interaction between confidence and sampling size works in the online manuals. So I'm not going to cover that here. However, what I am going to cover is the fact that it is not documented at all, that if you put in a value that is less than 1 or equal to 1, then that value is treated as a percentage of the rows to process rather than a number of rows. Okay, that's not at all documented, but I have tested the hell out of this, even recently. I'm not relying on my tests from the past. Even in version 15, this is still true. So if you have a value of 0.01, which is 1%, okay, that will also set a less than 1%. That will also set a confidence level for you. Otherwise, the confidence level will be set to 0. So if I put in, let's say, 0.5, right, meaning 50% of my data, it will sample roughly 50% of my data. Right, I have a table that I tested on that has 220 some odd thousand rows. If you do update statistics medium with sampling size of 0.5, it samples 123,000 rows, plus give or take a little bit. Okay, sampling size was first available in version 11.10. So if you're still running version 10, you don't have this option. Okay, the number of rows that medium will sample without a sampling size specification can be very low, much lower than you would imagine it should be. Okay, if you have a very volatile table, that is the perfect place to use a percentage, a very small sampling size, less, for 1 or less. If you set the sampling size to 1, it will sample every row in the table. Okay, just like high does. So there, the resolution will determine the number of bins for you, and that will make it, with the default number of bins being only 40, the stats won't be as useful as high would be with a default of 200 bins. Right, but you could adjust that. Okay. So recommendations. What we're always trying to do with update statistics is balance the time it takes to get those distributions calculated and saved on disk, because that affects performance of the system while that's all going on, because it's a highly IO intensive process, and it beats the crap out of the buffer cache. So we want to minimize the time it takes to calculate the stats, but we also want stats that are as useful as possible so that the optimizer makes really good decisions. And that's the trade-off that we always want to take, okay? These recommendations are geared towards that goal. So what you want to do is update statistics low on your database on a regular basis, whether that's weekly or twice a week, so that the basic statistics are relatively up to date. Okay, if you have very highly volatile tables, though, then I would do an update statistics low on those tables, maybe even every day. Then you want to do update statistics medium with distributions only, because you've already done a low. You don't need those low level stats to be calculated by the medium. Okay. For selected tables, and you could do the whole database if you want, if time is available. Okay. But you can also only do specific columns in the table that are not going to be done high. Okay, that can save you a lot of. You want to execute high after that. Also with distributions, well, also not with distributions only, sorry, for all columns that are listed first in an index key, right? So if you have an index with column A and an index with column B and an index with column Q, right, then A, B, and Q need high statistics. The other columns you can live with medium statistics in general. If you have multiple indexes that all start with the same column, say our column A, but one index is A and B, and another one is A and C and D. You also should do high for the first column that's different between the two indexes. So that would be B and C, okay? In addition to doing A. Non-index columns that are used in joins, I highly recommend also doing high on columns that are typically used in joins that are not the leading column in an index. That's a rare thing. Pretty much we create an index, that leading index for all of our join columns. But if you have any that are not, I would do a high on them anyway. And also any non-index leading columns that are used frequently as filters in where clauses, because that will help the optimizer make decisions about which indexes to use. Okay. Or rather which order to process the tables in, sorry. Optionally, you can also create high on columns that are used in partitioning expressions. Okay, if you use a lot of partitioning and your partitioning expressions are complex, that can improve performance and help the optimizer do partition elimination and parallel processing. Okay. You also want to set PDQ priority. Okay, when you're running update statistics, but only when you're doing it for tables, never for when you're compiling your store procedures. We'll talk about that in a bit. Okay, because if you compile a store procedure with a positive PDQ priority, it will always run with that PDQ priority. So if you compile, and since you only have 100% of resources to give to PDQ processes, if you compile a stored procedure with a PDQ of 100, only one copy of it can run. Any other sessions that call that procedure will have to queue up behind it and wait for PDQ resources to be freed up. So you single thread that procedure. If you set it to 50%, PDQ 50, then only two at a time can run, etc. Okay. So it's always a good idea to compile your stored procedures with PDQ priority 0, so that they will run with the current session's current PDQ priority, which is typically 0 in most of our installations. Okay. When you're running medium or high, you want to give it as much memory as possible. The best way to do that is to set PDQ priority and set DS total memory as high as you're willing to allocate. for parallel processing. Okay. And if you're running your update statistics with PDQ priority 0, you have to make sure to set DS non-PDQ priority mem, the PDQ query mem, to a value up to 25% of the setting of DS total memory. Okay, that's all documented in the manual, so you don't have to remember this. But the default setting for DS non-PDQ query mem is very low. So if you look on your system and you look in sysmaster sysprofile and you see a lot of disk sorts, that means your DS non-PDQ query mem is probably too low for even regular sorting, let alone update statistics. Okay. You could also enable parallel sorting without setting PDQ priority if you have issues with that by using the psort environment variable in the environment that's running the update statistics. Okay. You also want to enable as much temporary space for sort work files as possible. That would either be having at least 3 and as many as 6 DB spaces, temporary DB spaces listed in DB space temp, or having at least 3 file systems set in the psort DB temp environment variable in the session that's going to run update statistics. So, and those file systems that you're going to set into psort DB temp can be virtual file systems. They can be in-memory file systems, which will be very fast. Okay. And also, as of 11.10, you can create your DB space temp in a virtual file system, in a memory file system. And since as of 11.70, I believe that's specifically supported by the engine. So when you shut the engine down and restart it, as long as the virtual file system exists, the engine will use it and set it up. You don't have to initialize the DB space each time you reboot anymore. Okay, in the older versions, you had to do that if you wanted to use memory file systems for sorting, okay, or for temp DB spaces. Okay, any questions? Put them in the chat if you have any questions about that before I move on to talking about do stats. Okay. So what is do stats? Do stats automatically generates what I believe are optimal update statistic statements for tables and databases using the latest performance guide manual discussion of the matter, and also a paper that John Miller wrote several years ago describing improvements to the way update statistics worked after that point and how to take advantage of those internal improvements. Okay, it has options to control pretty much everything. What databases are processed, what tables are processed, whether commands execute as output to a file or to schedule to run in the database in the task scheduler, or in a stored procedure that you can execute manually. Okay, or many other things, and also to set the granularity options like resolution and the sampling size and confidence. Okay, you can get, it's part of my utils 2 package, which you can get from this address. The URL will also be on the last slide if you don't know about it. Okay. So what are the basic options for do stats? If you run do stats question mark and actually with no argument or with no arguments, it will print out its usage with paging. Okay, so you can look through the options. -H server name, right, or server is the host for the server. It's not -H server, it's -H. Yeah, server name, including if it's a remote path. Okay. If you want to use a shared memory connection, you have to specify the -S option. Okay, because without the -S, do stats tries to open multiple connections simultaneously, and you can't do that through a shared memory connection. Okay. Also, if you do submit the -S option, you can only process a single database at a time. -D is the database spec. By default, all databases are processed. Okay, but you can put in a matches clause to only do your databases that start with ME, or something like that. Okay, if you put in the keyword all or an asterisk for the database name, then we'll process all databases. Dash T is matches specification for the tables you want it to process. If you will omit dash T or do dash T star asterisk, it will process all tables in each database that was submitted in the dash D option. Okay. Dash P enables processing stored procedures. By default, stored procedures are processed, but if you specify dash T or dash I or dash X, which we'll talk about, I think, on the next slides, um, then dash P is disabled by default. You have to submit the dash P to turn it back on again. Okay. Dash W sets the wait time in case it DoStats encounters something that's locked. Okay. There is an option to tell DoStats to use dirty read optimization when it runs, so it avoids most locks. But if you don't want to do that, then the dash W option lets you wait for locks. Okay. We talked about PDQ priority. So the dash Q option lets you set the PDQ priority that DoStats will use for processing your tables. And the dash P option sets the PDQ priority that it will use to compile your stored procedures. By default, the dash P option is internally always set to 0, no matter what you set the dash Q to, no matter what you have the PDQ priority environment variable set to. DoStats will always process stored procedures with PDQ priority 0 unless you tell it otherwise with the dash capital P option. Okay, and we discussed why for that already. Another way to specify tables are the dash I and dash X options. Dash I says what tables to process and gives you various ways to do that. And dash X tells DoStats what tables to ignore. Okay, assuming that dash T star or no dash T was supplied otherwise. So your options are dash I and a table name. That's not a wildcard, not a matches clause, just a straight table name. You can have multiple dash I options. So you can have dash I table 1, dash I table 2. You can have dash I at file, which gives you the path to a file that contains the names of tables you want DoStats to process. And you have dash I at without a file, it will read from standard in. So that's good for scripting, where you're getting a source of a list of table names from somewhere else. Okay, let's say from a file that you built that you don't want to process that way. Dash I with an exclamation point lets you specify either a where clause without the keyword where to select table names, or to filter out the table names that get selected. Or if you have dash I exclamation point, the keyword select immediately following the exclamation point, that can be an entire query that selects tab names based on any criteria you need. Okay. And dash I greater than proc name lists a procedure that you specifically want DoStats to recompile. Okay, so if you just want to recompile one proc, that's the way you do it. You know, it would be DoStats dash D database dash I greater than my proc. We'll just do that one compile. Okay. There's a new option as listed, which is in the latest update to Utils 2, which says, you know, after I've processed all the lists of all the I options, don't sort by tab ID, but process in the order in which I specified the dash I options. Okay. One user requested that because he wanted the tables processed in a specific order. Okay. And dash X is very similar, but again, it lists the tables you don't want to process. Okay. Also, in addition to that, to the dash X table name, dash X at file, dash X at using standard in, and specifying a where clause, there's no option to do a dash X exclamation point with a select statement, because you can just do a dash I with a select statement that ignores the tables you want to ignore. So that's easy to do without that. There's also a dash X database. Okay, so if you pass dash D star or dash D all, you can also put in a dash X option that says, well, process all my databases except database Fred. Okay, dash X spread. Okay. Dash dash, I think, did I skip one? No. Okay. Dash dash small tables high. So that specifies that any table with fewer than a certain given number of rows should be processed. Just process all the columns as high because that gives me the best distributions. And the table is so small that I don't care. It's not going to take long to process. Okay. The dash dash small table thresholds specifies what that row count is that decides what's a small table and what's a big table. Okay, small and big in lowercase, not when we're talking about version 15, small and large tables. Um, Note that you can also use the thresholds set in PH threshold in the SysMaster database that are usually used by AUS, by the auto update statistics. You just set the AUS small tables record in the PH thresholds table, pass in the dash AUS thresholds parameter, and DoStats will use that setting from the sysadmin table, so sysadmin PH thresholds table, so you don't have to specify dash dash small tables dash threshold every time. Okay, and that gives you a way of specifying and maintaining a default. That, by the way, well, we'll talk about the AUS thresholds option in another slide. By default, DoStats processes update statistics commands immediately, right? It connects to the database and runs them. So if you want to, you can say -f file name, and it will output the commands to an SQL file for you to process later. Maybe have a cron job that wakes up at 3 in the morning and executes the SQL in a file, right? And you can run DoStats to change the contents of that file periodically. --proc local creates a table of commands in each database along with a stored procedure that can be used to execute the contents of the table. Very similar to what auto update statistics does in sysadmin. Okay, and you specify the name. You can optionally specify the name of the procedure to use. Okay, when you're writing to proc local. Also, execute local, -- execute local is similar to proc local, but it executes the procedure connected to the local database. Okay, and you need that if you have any ANSI or unlogged databases. Okay, and you want to use the store procedure option. Okay. In some cases, especially after an version upgrade, which I mentioned before, it's highly recommended to remove all the existing distributions before running update statistics, and you should always run update statistics after a new install and upgrade. Excuse me. So DoStats provides two options for that. The -- drop distributions can only be used by user Informix. Okay, it manually deletes all the distributions in the sysdistrib and sysfragdist tables before doing anything else. Okay, you can't do that if you're using -t or -i or -x, because the assumption is that you don't want to lose the distributions in the tables that are not listed in -t, -i, or -x. So if you provide any of those options, -- drop distributions can't be used. Instead, we have -- clean distributions, which manually drops the distributions for each table one at a time before processing the new stats for that table. Okay. The -R lets you set the resolution. Okay. Yeah, set the resolution for high. Okay, for update statistics high. There's also the -- distributions high equals a file path, which specifies a list of columns that you want to force to be processed high, regardless of whatever else DoStats would otherwise decide to do. Okay, and those entries in that file are 3 columns, space separated: the database name, the table name, and the column name. So DoStats will decide if a table needs to have stats done. It will look through the file and decide if it should be high, if it should force high on that column, and then it will continue from there, one way or the other. Okay. For medium, the dash lower R sets the resolution, dash C sets the confidence level, and the dash capital Z sets the sampling level. Okay. Okay. And we talked about this quite a bit already. Reporting. You can modify the kind of reporting that DoStats does while it's running. Dash lower E expands the reporting to include the elapsed time for each step that it did. So it took me 0.8 seconds to process this column. It took me 0.2 seconds to process that column. And then it took me 1.2 seconds to process the table that contained those columns, etc. And then at the database level, and finally the whole run. Dash capital E expands that elapsed time reporting to have, instead of being in seconds and fractions of seconds, it's in hours, minutes, and seconds. So instead of seeing 120 seconds, you'll see 2 hours, 0 minutes, 0 seconds. Display time also displays the start and stop time for each section of the process. Okay. Optionally, you can say dash time display. They're both the same because I couldn't remember which one I put in all the time. So I put them both in. They mean the same. Display local just does the same thing as display time, except it displays it in the local time zone instead of in universal time. Okay, and the dash display subsec adds fractional seconds to the display, and it will turn on display time. Okay, but you can, if you put in dash display local, it will use local time instead of UTC time. Dash X enables set explain during processing, so you will get an SQ explain file that tells you what DoStats did and how it was processed, and how long each step took at another level internal to the engine. Okay, and you can use that to optimize some of the options you passed in. Okay. Dash capital V prints out the version and copyright information. Not particularly important unless you want to report a bug to me or a problem. I need to know what version you're running. Okay. Dash capital F disables a single column optimization. That's one of the things you might want to, you'll find out that you need to do if you run the dash X set explain option. So on some systems, especially those with limited memory and limited cache, disabling that single column optimization. So typically Informix does the high without the distributions only option, but if you have a single column index, then doing that single column, and there are no other indexes that start with that column, then it will do that column high, okay, without the distributions only option, so that it also calculates the low-level statistics for that index as well. Okay, and that can sometimes be important. Otherwise, Informix will do the DoStats will do the low level for that column separately. Okay, but again, on some systems, it's faster to do them together. Dash capital N, use the specific keyword when you're processing stored procedures. Some procedures, if you have overloaded procedures with the same name, you have to use the specific keyword in order to process and compile one of those procedures instead of all of them. By default, DoStats will include the specific keyword. Okay. Dash N error limit says quit after you get 2 errors, 10 errors, 100 errors, 1 error. Okay. By default, DoStats will just keep going and keep trying. Okay. I'm sorry. By default, it will quit on the first error. Sorry. But if you wanted to keep trying the next table, the next database, then you can put in the error limit. Okay. Dash error count reports how many errors DoStats actually encountered before hitting the error limit and quitting. Dash AUS thresholds we already talked about. That tells DoStats that wherever there's a threshold in the pH threshold table for aging, browsing, and small table processing, DoStats will use those thresholds and you don't have to specify them on the command line. Okay. Dash dash isolation equals the letters C, D, or L to specify what level of isolation and DoStat should use. Okay, it's committed read, dirty read, or read committed. Okay. Dash dash force run. So it says override the auto stat mode that defaults for the table or for the database as a whole, and always build distributions. What I tell my clients to do if they set auto stat mode to auto as their default and for certain tables, to run do stats daily without that, so that tables that don't need stats, that stats are good enough, are no opt during the run, and the engine ignores the request to update statistics. But then on the weekend or whenever you have a quiet time, let's say once a week, run with the dash force run. And in that way, highly active tables get new stats once or twice during the middle of the week, and your quieter tables always have up-to-date stats at least once a week, right, when you run with the dash dash force run. Dash dash auto run overrides the auto stat mode if that setting is cleared, right, is not set, and forces auto mode when the update statistics are run. Dash M tells DoStats to process your catalog tables. You only really need to do that periodically on a production system because your catalog tables change very rarely. But if you certainly on a development system or a QA system with you're adding columns and tables all the time, processing your catalog tables periodically is a good idea. I would do it once a year, even on a production system, because it take very long. Also, if you have a tremendous number of users and user permissions on a tremendous number of tables, that can get very inefficient. And the processing distributions for your catalog tables even more frequently will help with that. Okay. Dash G says also process fragment by expressions, columns that are used in fragment by expressions as high instead of what might be the default, which would be medium if they're not in an index otherwise. Okay. The environment variables Informix user and Informix pass can be used if you need to connect to a database using a specific username and password other than your own, the one that's running the session. All right. Now, there's another thing in the utils2 package that is less well known, is the drive do stats. That's a script that will partition your tables and run n copies of do stats against sublists of your tables. Basically, what DoStats does, what drive DoStats does, is it lists out your tables by size, number of rows, and then it will distribute them round robin, biggest tables first, or optionally, we'll see smallest tables first, to n copies of DoStats using the dash I option. So it will create n lists of tables from biggest to smallest in each list, or from smallest to biggest in each list, and run that. That can run things, your database much faster if you're running this on a quiet time where you can afford the CPU cycles and the IO overhead of running 2 or 10 copies of DoStats in parallel. Okay, and that would be for for one database. So it goes like this: drive DoStats, number of procedures, the database name, a table spec if you only want to process a subset of your tables. You can pass in the dash X and dash I options, okay, with the @ sign for a file listing the tables you want to exclude or you don't want to exclude, or without the dash @ with a single table name that you want to include or exclude, okay. And then the dash A option says to sort by smallest to largest instead of largest to smallest. So if you want to get a lot of small tables done real quick, add the dash A option. Okay, by default, the biggest tables are processed first because they get you the biggest bang for the buck. Okay. Any other DoStats options you want to pass in, almost all of them are passed through drive DoStats to the underlying copies of DoStats that are being run. So you can pretty much pass anything you want that's not right. The dash X's and the dash I's are processed directly by drive do stats. Anything else pretty much is passed on through to do stats. Okay. What's that? If you try and mix dash X's and dash I's, the excludes only apply to the tables in the dash I and vice versa. So it gets a little weird. Okay. And note that there are a couple of options, pass-through options that will not work properly. Okay. So here's some testing. Right, I ran do stats on a with force run against one of my databases, and it completed in 0.8 of a second. I added a dash Q100 to use more processing. That didn't help. It actually slowed it down significantly. But then I ran 7 copies of do stats using drive do stats. Each run creates its own run log. Okay, and then there's an overall. There's also a log file for procedure calculate compiling, and that ran in half the time. Okay, I have 12 cores on my system. I have 2 performance cores and 10 um, general cores on my laptop. So running 7 copies was pretty much done by 7 different processors, and that ran in half the time. So that's pretty good. Okay, some of the tables are rather large. That's it. You can find this once we get the recording saved and cleaned up and moved up to YouTube. You'll find this recording and recordings of other tech talks on our Tech Talks in IIUG Tech Talks channel on YouTube, and there's the URL near the bottom. Right. And thank you. That's the URL at the bottom there for my utils package.
Thank you, Art, for doing this talk. Are there any questions out there?
All right.